Good day to all of you. Today we shall discuss on the topic trees in data structures. My sincere thanks and acknowledgement to the authors Ellis Horowitz, Sarta Sani and Susan Anderson Freed, the authors of the textbook with title Fundamentals of Data Structures in C. The whole content of discussion I have taken from this textbook. This topic is studied in the subject Data Structures and Applications with subject code BCS304, which third sem students of CS and allied branches do study. It comes in module 3 and continued in module 4 of the subject. Firstly, what is tree data structure? Tree data structure is a hierarchical structure that is used to represent and organize data in the form of parent-child relationship. Means whenever in real life we have data, between data if parent and child relationship is there, that kind of data is stored in the form of tree data structure. The examples being folder structure, because we have main folder, under that subfolders, again subfolders. So there is a relationship between main folder and subfolder as parent-child relationship. So this kind of data is stored in the form of tree data structure. Another two examples are file system on a computer, tag structure in HTML. So HTML in the sense hypertext markup language, which is used to design front-end sheets in the web development. So what is tree? Tree is non-linear data structure which organizes data in hierarchical structure, and this is a recursive definition. It is collection of data, means we store data in the memory. The data stored in the memory, they are called as nodes, and these nodes are linked. They are organized in hierarchical structure recursively. So this is an example tree. Tree has nodes and links. So here A, B, C till K, these are called as nodes. The connecting links between any two nodes, they are called as links. If a tree has n nodes, 11 nodes, it will have n minus 1, that is 10 edges. Next we shall see to the different terminology that come in tree topic. So tree has nodes and links. So the nodes may be root node, parent node, child node or sibling nodes, internal node, leaf node. Then another term, what is degree of the tree, what are the levels in the tree, what is height and depth of the tree, what is meant by subtree and forest. These are the different terminology that come in the topic tree data structure. So the first term is root node. So the first node in any tree is called as root node. There can be only one root node. Then we have edges. The connecting links between the nodes is called as edge. So if you take G node and K node, the connecting link between the two nodes, for that matter any two nodes, they are called as links. So if a tree has n number of nodes, it will have n minus 1 edges. Next, parent node. In any tree data structure, any node in the tree which is a predecessor of any other node. So B node, if you take, it is predecessor of E node, hence B node is a parent node. If you take C node, it is a predecessor of G node, hence, and H node similarly. Hence C node is the parent node. But if you take K node, H node, the I, J node, F node, I node, D node, these are not a predecessor of any nodes. Hence, they cannot be parent nodes. Hence, in this tree, A, B, E, C and G, only these nodes are the parent nodes because they are the predecessor nodes of some other nodes. Next, child node. So in a tree data structure, the node which is a descendant of any other node, then it is called as child node. B is a descendant of A, hence B is called as child node. Similarly, C node is the descendant of A. So C is the child node. So here B and C are the children of A. Then G and H are the children of C. K is the child of G. I and J are the children of node E. So descendant of any node is called as child node. Then sibling nodes. In any tree, children of same parent node are called as siblings. Here D, E and F nodes are the child node of B parent. So they are the children of same parent node. Hence D, E, F they are called as siblings. Similarly, B and C are siblings. So here B and C are child node of A. So they are children of same parent. Hence B and C are siblings. Similarly, G and H are siblings because they are the children of parent node C. I and J are the siblings because they are the child node of same parent E. So in any tree, the nodes which has same parent, they are called as, those nodes they are called as siblings. The children of same parent node are called as siblings. Leaf node. Leaf node means the nodes which do not have child node, they are called as leaf nodes. Other than leaf nodes, all other nodes are called as internal nodes. So leaf nodes are called as terminal node, external node also. Similarly, internal nodes are also called as non-terminal node. So these are leaf nodes or terminal nodes. The remaining are, they are called as internal nodes or non-terminal nodes. Next, degree of the tree. In tree data structure, the total number of children of a node is called as degree of that node. Suppose if you take this node B, so the total number of children is 3, D, E, F. Hence degree of B is 3. Similarly, A is 2. So this node if you take A, B and C are the two children. Hence the degree of A is 2. Similarly, the degree of F is 0 because it doesn't have any children. So in any tree, degree of the node is total number of the children it has. But degree of the whole tree means the highest degree of the node among all the nodes in the tree is called as degree of the tree. Degree of the node is how many children it has. Degree of the tree is highest degree of the node among all the nodes in the tree. So for example, if you take this tree, it has nodes A, B, C, D till M. So every node if you take how many children it has, A and D nodes, they have 3 children. So this A node, it has 3 children. This D node, it has 3 children. Hence the degree of A and D nodes is C. D nodes is 3. Similarly, B and G nodes is 2. C and E is 1. And all other nodes do not have any children. The maximum degree of the node among all the nodes in the tree, that is 3. Hence degree of the tree is 3 here. Next, what is meant by level? So here in any tree, the root node is said to be at level 0. Its children will be at level 0 plus 1 means level 1. If this is level n, this will be n plus 1. So if this is at level 1, next the level of its children is level 2. Then the last level is 3 here. Further, we don't have any child node. Hence, this is the last level. So in a tree, step from top to bottom is called as level. Step from top to bottom. So this is top, this is bottom. So this is step, that is the starting step, that is level 0. As we move forward and move from parent to children here, the level is incremented by 1. Then what is height of the tree? In any tree, height of the node means total number of edges from leaf node to particular node. If you take, see here, from leaf node, if you pass, so only one link we have to pass through. Hence, height of the node C is 1. But this way also we can move to C. This is also leaf node K. So first K to G one link, then G to C second link. Among these two, so here it was, the height was 1, here the height is 2. So among the two possible paths, the maximum is 2 here. In a tree, height of the root node is said to be height of the tree. So this is the root node. Suppose if you traverse from leaf node H, 1 link, 2 link, this way the height is 2, but longest we have to consider another possible path. So from K to G, G to C, C to A. So the height is 3. Similarly from this path 1 to 3. So the maximum is 3. So the height of the tree is 3 here. And one more point to be considered, height of all the leaf nodes is 0. Because K to K, if you traverse, the number of links that we have to pass through is 0. And height of K is 0. Similarly, all leaf nodes, their height is 0. So an example tree, if you consider here, A to M are the different nodes. So from leaf node, if you traverse to root node, that is height of the tree. To any node from leaf node, longest path if you traverse, then we can find the height of that node. So height of A is 3 here. So A is the root node, the longest is this, from this low leaf node, M to G, G to C, C to A. So through 3 links we have to pass through or traverse through, hence height of node A is 3. B and C if you take 2. So this B if you take from leaf node K to E, E to B. So from F to B it is 1, K to B it is 2. The maximum is 2, hence height of the B node is 2. This way the height of all the nodes is written. The height of root node, that is A, which is maximum, that is called as height of tree, which is 3 here. Next term is depth. To find the depth of any node, we have to traverse from or move from root node till that node. So depth of B. So from root node if we come, we have to pass through one link, hence depth of B is 1. Similarly depth of C is 1. But H is, if you come through, it is 2. But of K is 1, 2, 3. Depth of K is 3. So this is the maximum one, hence the depth of whole tree is 3. So this way we can find depth of all the nodes. In that, which is the maximum value of depth, that becomes depth of the tree. Next, considering this example tree, depth of A node is 0 and all these 3 nodes, they are in the level 1. If this is level 0, this is level 1. Depth is 1. Then depth of all these nodes is 2 and depth of all these leaf nodes is 3. Hence, the depth of whole tree is 3. That is 3. The next term is path. In a tree data structure, the sequence of nodes and edges from one node to another node is called as path. So one node if you take A, another node if you take D, then A to B, B to D if you write, that is the path. Similarly A to J, so we have to write A to B, B to E, E to J. So that is what is written here. So this sequence of nodes A to B, B to E, E to J, that is the path between A and J. The path between C and K is C to G, G to K. C to G, G to K, that is the path. So in this example, if you see, so path includes all the nodes and edges, not just edges. So the path from A to K. So A to K, if you take A to B, B to E, E to K. The direction of path is strictly from top to bottom. D to K is not possible. So this D and K, the path is not possible. We cannot move from top to bottom strictly here, because first from bottom to top we'll have to move, then we'll have to come from top to bottom. Hence from D to K the path is not possible. But between A and K is possible, because A to B, B to E, E to K, that is from strictly from top to bottom we can move. This collection of edges and the links between the nodes is called as path. In the last term is subtree. In a tree data structure, every child node will form a subtree on its parent node. So if you take a parent node, this child node with remaining nodes and links, it forms one subtree, and here we have another subtree. So B parent node, if you take this child node and other links with other nodes, that forms another subtree. So in a tree data structure, every child node will form a subtree on its parent node. And that completes the whole discussion. What is tree in the data structure topic, and then what are the different terminology involved in this tree data structure topic. I hope you understood. Thank you.